Great. Thank you. And thank you, everybody, for taking part in the chat. I'm really excited to be presenting today. And thank you, Rachel, for inviting me to do so. So I picked using generalizations to assess for understanding, because I think a lot of us are good at writing generalizations, but kind of like, what do we do with the children's ones? So we're going to focus on that today, but a little bit more about me. Some of you know me. But for those of you who don't, this is me. My name is Patrick Renouf. I'm an independent coach at the moment, helping schools with their CBI work. I'm one of the co-authors of the units in the mathematics project. I can't remember now, was it 2 years ago? I did my certified Ericsson Lanning CBCI trainer, about then, I think. Most recently, I was a grade 5 team leader at ICS in Zurich with PYP, and we introduced the CBI math there. And then before that, I was the maths coach, K-5 at UWC in Singapore. And that was quite a surprise to me, because you'll see the word there, maths trauma. I was the person who had a terrible time with mathematics, both as a student and teaching it. Like, I tell people that I used to write my schedule on the board, and when I wrote maths, I would get like a knot in my stomach. So it would be the thing I would happily drop from the day. Yet you'll see there's a picture of me with Jo Bola. I got to meet her in Portland last year, and it's a lot of her work that led me to this point where I'm speaking to you now. So things can change. A little fact about me is I'm from Old Jersey. Everyone's heard of New Jersey, but Old Jersey is sitting there. It's a little rock in the sea, half the size of Malta. I saw lots of Malta people come in. So it's half the size of Malta, and it's just between France and England there. I'm also a massive Eurovision fan, and I know most of you will be concerned whether I have tickets yet. Yes, I do. So that's a little bit about me. But let's move on, because actually, copyright reminder. So please do not take screenshots or recordings, and only use things for your personal use. Thank you. So let's move on, because we are here not to talk about me, but to talk about our generalizations and how we can use them in assessments. So these are our guiding questions for today. We're going to do a quick whistle-stop tour through what a concept-based approach is, because I'm not entirely sure of where everybody is on the spectrum about that. We're going to look at ways traditionally we've assessed maths, and we're going to move forward into sort of conceptual understandings. And then I've got a load of children generalizations for us to look at and how we might use those. So first of all, what is a concept-based approach to mathematics? This may be familiar to many of you. And we'll start with the idea that traditional curricula were quite often very two-dimensional. So they focus on skills and knowledge. And it's an inch deep, a mile wide, and kind of has that idea of coverage. But when we're with a concept-based approach, we really have a three-dimensional approach where we use those skills and facts. We're not saying they're not important, but we use them to build up to that conceptual understanding where the children create their own generalizations, and that's the learning they can take with them, because often those skills and facts get kind of locked in time and place, whereas once we get it up to that conceptual level, they can move it forward and take it with them in their learning. So that all comes from the structure of knowledge developed by Lynn Erickson. And it took me a long time to realize, even when I was beginning out as a maths coach, that mathematics was a knowledge-based discipline, because the way I'd been taught mathematics was so procedural. I was like, it's got to be a process-driven discipline. But there is obviously processes in mathematics. That's one part of it. But it is a structure of knowledge, a knowledge-based discipline. We do look at facts, we look at case studies, bring them together and take them forward. In our concept-based approach to mathematics, we work on an inductive approach. And if you look at the bottom here, Andrea's drawn the deductive approach. This is how I was taught maths. The teacher provided me with a generalization, a truth they brought to me. And then we looked at lots of examples of that truth and practiced it. And at the end, we were meant to validate it. Well, I think a lot of the other students in the class validated it. I never really quite got to that point, it feels like. So that's not me going, yep, that's right. But in an inductive approach, we invite the children into the inquiry using questions. We invite them in to start exploring those factual examples, those case studies, looking for patterns, and then bringing it up to form generalizations. They do the hard work. They create that thinking, and then they take it with them because that learning is deeper. And that's the synergistic thinking we're talking about. This is something I've developed because this is how synergistic thinking looks to me. So you have synergistic thinking is the skills and knowledge, sort of like lower level thinking, and then that conceptual higher level thinking. And you're forever scooping down into the skills and knowledge and bringing it up into the conceptual. So it's kind of always this scooping up, but I like the fact you kind of have to loop back sometimes, you loop a bit forward, but it's always this forward motion. If synergistic thinking is a new phrase for you, or you're like, wait, I have read that somewhere, this is how I remember it. Synergy is the interaction of basically two separate things, and their combined effect is greater than the sum of their separate effects. So for example, here we have a bee and we have a flower, both beautiful things individually. Together, they produce so much more. So I don't know, I suppose the bee could be the skills and knowledge, the flower could be the conceptual thinking. Together, they produce so much more. And that helps me with that synergistic thinking. So that's why we're bringing those things together. The wonderful thing that Rachel and Carla have done is created a pathway for us as teachers in order to make that all happen in our classroom, that theory. So the concept-based, the inquiry cycle here really does bring that structure of knowledge up. It helps with that synergistic thinking, and it helps create those generalizations to that transfer. So all my learning, when I'm teaching, I've always got this in my head. All my planning is based on this. So that was a whistle-stop tour, but if you're new to conceptual approach in maths, that was a whistle-stop tour, but we can do more on that another time. But here we're going to start dipping into what has been the traditional method of assessing mathematics. So the one on the right might be very familiar to some of you. That's from the JAMS, that's from the New Zealand assessment. I know a lot of schools use this. And then on the left, I've taken that from the Common Core sheets. And so what I'm trying to show here is that quite often, I know I did this a lot, when I was collecting data and assessing children, I was really only ever looking at their skills and knowledge. Can they perform? Can they just get the answer, basically? I'm not saying there's not anything wrong with this, because there's a lot of good stuff, especially JAMS does give you a lot of information, and it does provide what I call longitudinal data. So not what I call, what everyone calls longitudinal data. So a lot of schools, I would say assessing skills and knowledge form the basis of much school data. So those JAMS give that longitudinal data. External assessments, for example, like sometimes they're called the ISAs or sometimes they're called PISA. Those are often what schools use. And I feel like those spend a lot of time in the kind of like skills and knowledge area. I know a lot of my unit assessments, summative assessments, when I was teaching sort of way back, those were all skills and knowledge based. And then you've got your formative assessment. These three levels of assessment to me form the triangulation of how you assess and be able to sort of give feedback and report on where the child is. But when you think about it, how might assessing the conceptual understanding be a powerful part of that triangulation? How could those conceptual understandings add to the longitudinal data, to the summative assessments? And then you've got that assessment data, you've got your student reflection and teacher judgment to help give you that idea of where the child is. I've always been very lucky to work at schools that have never wanted a grade for our primary children. It's always been working at grade level beyond or approaching. And this has always helped me to do that. But having conceptual understanding in there really adds depth and kind of meat to that assessment. We'll come back to this at the end to answer that. I'm not going to do it now. So that's a bit of suspense for you for later. So what often happens when we only assess skills and knowledge? This picture does have a purpose. First of all, when we're only assessing skills and knowledge, if you think back to that original 2D, inch deep, mile wide, we're really just coverage. We're ticking off standards off a list. That's great for us as teachers because we're like, oh, I'm such a great teacher. I've got through all this. But for the children, it leads to like a fractured understanding of mathematics because they're not pulling those parts together. And That's where these Tetris bricks come on this side. When I was a child, it felt like Tetris. It was like, oh, here's another brick coming down that I have to deal with. Here's another brick. Oh, and the music's getting faster. And I can't put it all together. And I don't know what I'm doing. So if we are assessing only skills and knowledge, it doesn't always give the children a chance to zoom out and get that bigger picture. And what we want is that knowledge and skills to compress to create more space so that they can bring in more bricks, if you like. If we only assess skills and knowledge, we're really valuing performing over thinking. And we're valuing rules and procedures over number sense and agency. In Jo Boaler's last book, she talks about how number sense is the biggest indicator of a child's achievement in mathematics, because those high-performing mathematicians have incredible number sense. And if we have rules and procedures, that really limits number sense and building that agency. So we have to be careful about what we're promoting sometimes. If we are assessing conceptual understanding, it's much more inclusive. I know that the children who are the writers in my class, when it comes to writing generalizations, they find more of a place for themselves in mathematics because they enjoy writing them. And also it values that thinking and connection and honors that synergistic thinking, which is so much deeper than just regurgitating rules and performing procedures. And it leads to that transferability. It also broadens our view of mathematics. So often we just focus on sort of calculating as mathematics. Mathematics is a broad, creative subject. And one I remember hearing for the first time from the maths coach that I was working with, the beauty of mathematics. And I remember thinking, I'm sure this person must have a fever, because to me, I wasn't sure what the beauty of mathematics was. But the more you do it, you see it's there, and we allow the children to see the beauty of mathematics, just like we love them to see the beauty in reading and writing. So first of all, assessing using a conceptual understanding obviously needs to be intentional. So we need to plan for it. Our curriculum is the learning terrain. I speak in metaphors, so I hope that's helpful. But for me, one of the most powerful metaphors about planning has been the learning terrain. And our curriculum is the learning terrain, but we need to map our units out. We would never take children to a mountain range like this or hills like this and say, off you go and explore. It would be very stressful and quite dangerous. So we need to make sure we're really mapped out. What are we exploring here? What are the major landmarks we want the children to visit? And what are the possible routes? So in your learning terrain, in your unit, that's your 5 to 9 generalizations, which are built from the skills and knowledge. And that creates that lovely flow of learning that you're in charge of, that you can sort of help the children through so they can explore the routes they need to explore. And along the way, just like you would if you were hiking, you have an assessment point. When I'm hiking, I often think, do we need to stop for a sandwich? And I know that's not quite the same thing, but it's like we're stopping, we're checking in. Is everyone okay? But most importantly, we're not going to send the kids off on a hike unless we're sure they're ready for it. And that's the pre-assessment and the mess about. So the learning terrain, I find quite a powerful image for our curriculum and our mapping. Where are we having the children walk? What are they exploring? So let's have a little look at pre-assessments. Oh, no, let's not. Sorry, that's later. First of all, this is the learning terrain for one of the CBIM units that Jess and I worked on. When we were mapping this out, we started with understanding 2 here, which was creating systems for classifying shapes. And as we got into that, we realized in order to do that, the children needed angles, and they needed to understand angles. So we put the angles one further down. We brought it to the start, and that became the coat hanger on which all the rest of them hung. And everything flowed from this one thing. So getting your understandings in the right order that you want the children to experience builds on that idea that mathematics is this hierarchical subject. And everything stemmed from this study of angles and rotation into creating shapes, right up to the idea that you can do transformations on the coordinate plane. So our ideas also built in sophistication. And so having that really mapped out for you as a teacher is very powerful, because you need to keep those conceptual understandings in your head so you know the children are heading towards it. So you know if you can assess them. So let's zoom in on one understanding. So in my metaphor, there's the picture of the learning terrain, and on the right is the theoretical learning terrain, what it actually looks like in terms of the structure of knowledge. So here's what we have. We have our understanding. People classify and name angles according to the amount of rotation. We have the associated skills and knowledge. And then in order to create that flow, we have those guiding questions. You have sort of like one of these for each of your understandings so that you know you're building up to that generalization, that conceptual understanding. Now let's look at pre-assessments. So we're going to think about how we can use pre-assessments to help assess for conceptual understanding. But first, your turn. In the chat, I'd love to know, are you actively using pre-assessments in mathematics? But also, what do you do with the data?
I love that second part of the question, Patrick, because I remember working in schools and then saying to the teachers, and what did you do with the pre-assessment data? And they were like, oh, well, we just kept teaching the learning engagements that we'd planned. So it's all good and well to have a pre-assessment, but thinking about how you use that data to inform practice is so important.
Great. So we have some coming in with low floor, high ceiling activities. Fantastic. Observe and collect. Student examples to drive instruction. Okay, we've got some people who don't, and that's fine because we're all at different stages. Yeah. Yes, exactly. It lets you know how to differentiate. It helps gather the prior knowledge and evidence, sometimes to inform teaching. Fantastic. There's some great stuff all coming in. The data is the starting point to redefine the unit planning. I love that. Yeah. Because sometimes you plan a unit and then you're like, oh, wait, we need to do this instead. Fantastic. Establish prior knowledge and gaps, and it helps with differentiation. Fantastic. Okay, well, I'm going to keep moving on. You can keep adding those to the chat, Rach. If you see anything juicy pop in, let me know. And here we go. So I've done this a lot as a teacher. I've kind of done my unit a bit like this: pre-assessment, summative assessment. And that was how I spent a lot of my teaching career. And it sort of implies you have all the children here, and basically you kind of want to do that. And everyone's like getting them there. And as we know, that's not really true in terms of sort of teaching. So as people have mentioned in the chat, we're assessing, have students understood the previous learning and understanding, and what do they already know about the learning you're planning? And today, as I was thinking about this, I didn't find a photo, but it made me think of the Roman god, because we're in January, the Roman god Janus, who has two faces, one looking back and one looking forward. And it's like, what are the children bringing with them? And what do they know already about what we're about to do? It's important to know this. So here's some strategies I'd like to share with you that help me bring more meaning to the data that I collect from the pre-assessments. So first of all, in terms of structuring your pre-assessments, in the CBI maths project, we generally go for around 6 questions per unit. And that gives you 2 sides of A4. It's not overwhelming for the children. And if you ask the right questions, you really get a load of information. And try and keep it around 6. What I then ask the children to do, and I think this is a lovely strategy, some of you may already know this, get them to highlight. First of all, that encourages them to read the entire assessment before doing anything, which is always a good skill. But second of all, they go through and they highlight pink for things that look new, like I've never seen that before, there's something about this, I don't know. Yellow, this looks familiar, but I'm going to take a moment with this. And green, I know this, I've done this before. And it's really, and then I say to them, okay, once you've done that, start with the green, get those done, then go to the yellow, and then go to the pink. And it sort of shifts their thinking, especially in primary school, that they have to start with question 1 and go to question 6. They don't need to. They can do the ones, they can start with their strengths. And the other thing as well I do is let them write notes to me, because sometimes that makes assessing them much more entertaining, but also it's really interesting. So this one here, the student on question 4 has marked it pink. And if we didn't have the note there, so the note says only 5 line segments. I thought there should be 10. So this tells me a lot about her previous experience with number lines. Between the 0 and the 1, there's only 5 separations. She's clearly used to there being 10. And if I didn't have that note, I would just think she's got this wrong. I don't understand. This note has given me a lot. So she's clearly grappling with where to place these decimals, but doesn't quite get it. So, and she's marked it pink clearly because of that. And that's giving me a lot of extra data rather than just she got it right, she got it wrong. Okay? And I love the fact that children write notes, because once I had on a pre-assessment years ago, it was a long division, grade 5, and it was done perfectly. It looked beautiful. It had the correct answer. And underneath, the child had written, "This took me ages," ages in big capitals with 5 exclamation marks. And I was so happy they'd written that, because if I'd just seen it was right, I don't know whether it took them 30 seconds or 30 minutes. And so it was really good to get that. So always let the children write notes to you. It gives an extra layer to their thinking. Now, this is my highlighting. So the first part was children facing. This is adult facing. When I then assess the children, I have my own little system. So I'll fill in my spreadsheet, and red would be the child shows no understanding, or there's no answer, or there's a wrong answer. And so I can put that in red. Yellow shows some understanding, or there's understanding there, but they've ended up with the wrong answer, or a correct answer with no understanding. I don't accept just a number, because first of all, it could be a fluke. But second of all, if the child can't explain how they got there, then do they really understand it? And then green is obviously, yes, there's understanding. Yes, there's an answer. Great. And what that provides me with is like this heat map of the unit. And I can see where we're sort of heading and what things might look like. And it helps me know if I've got the children in the right phase, where they need to start, maybe which understanding. And that really is a really healthy way. And I'll add to that, they're highlighting their mental mindsets about it and their notes, and I can start to make my own judgments about that, rather than just if I gave them a grade of 4 out of 6 or something. This is much more healthy. And then generally I end up with something like this. That's what my class looks like at the beginning of every unit. And you're like, okay. But it gives me an idea of where they are in that learning terrain and where we can start from. And a lot of you mentioned that in the chat. So just a little review there. How do we plan to assess? We make sure we've got those 5 to 9 generalizations. We plan those pre-assessments to show where everybody is on the terrain. Hotspotting, that's something I didn't mention. That's a term we've got in the CBIM where you realize that they've got most of the understanding, but there's one little bit missing. So you need to go back and hotspot them to build that back up, and then they can just jump straight into the next part. Also, student voice, remember to add those notes. And something else I love, because I told you this, metaphors. I like to get the children to a little exit ticket saying something like multiplying fractions is like. And the best one I ever had, and I didn't take a photo of it, one of the boys had written, multiplying fractions is like driving a car. I don't know how to do it, but I can't wait to learn. And I was like, that's so lovely that they do it. And then you get other ones where it's just, it gets, they tell you it's like a sundae. You have bits you like and nutty bits you don't like. And they start to tell you a bit more. And it just adds a bit more joy to mathematics.
Patrick, there's a comment in the chat that says, is it not time consuming? And I think that was specifically in reference to the work that you do as a teacher, going back to kind of put that data into spreadsheets and be assessing students in that way. So do you want to speak to that investment of time?
So for this, because you've got six questions and they're pretty meaty, it doesn't take me too long, and you get a lot better at learning that. You also remember, alongside this, you often do your engage phase and your mess about. Well, sorry, you just do your mess about. That's before the engage phase. And during the mess about, those are sort of like activities or learning engagements that start to bring some of these things to life. And you can use that to talk to the children as well and conference them. And that then starts to flesh it out. And you know what you're looking for. And if you conference with the kids, you start to, and if you know your children well, I found it quite sort of not too time consuming, but I also found it a lot more interesting than just putting ticks and crosses on something. And it was a lot more sort of like pleasing. So I was happy to spend the time doing it. Something else I would say is we did these pre-assessments well in advance of a unit so that we could make sure we knew where we were heading in a few weeks' time. So if we needed to make alterations, it was planned out that this would be a few weeks before so things could happen. So I had time then also to add that assessment in. But I didn't find it overwhelming. And I'm the kind of teacher who, if something's overwhelming, I will find ways to do it in a more efficient way. But I know it can be quite scary when you're running a class full time.
There's also one other question, and it says, are the generalizations from the pre-assessment the unit generalizations or related previous knowledge that's the foundation needed for the unit?
It's a little bit of both, really. We in the CBIM project, we are definitely more assessing the previous phases, understandings to make sure they've come through with those. But also there's a few things you might want to preview to see if they're ready for it. And that's what I mean, like that sort of two-headed god of looking back and looking forward. You need to get a nice mix of, have they got that, remembering it's hierarchical, this subject, have they got that foundation for the next part? We don't want to build a bridge without the supports in place. I hope that answers that question. Anything else you spotted in there?
I think you keep going and I'll pick it up.
So the next part of all this, you're probably thinking, I thought I was just going to look at generalizations. We're looking at how we capture student understanding during the inquiry. So that's basically it. Along the learning terrain, you need to have lots of times planned in where you stop and check, do we need a sandwich? Is this where we've got the right idea? Are they ready to go on to the next part? Okay, and those student reflections. So remember to sort of put those in. And we're going to go into more detail, but every learning engagement is an assessment opportunity. And if you're using low floor, high ceiling engagements and stuff, you get a ton of things out there. But one of the things I think we do well in the CBIM is having this skills and knowledge checklist. You've got them there. And then if you can add to that, like as you would conference with children and speak to them, you can be like, and you can add notes to these. Say, I think they're getting this, they've got that, they showed good understanding here. And as you're assessing that, you're always considering that flow of learning up to the generalization. We're going to get to the top of the mountain. And how will these skills and knowledge build up to this understanding and beyond? That's my Toy Story moment. I keep thinking the Buzz Lightyear to understanding and beyond. We're not just getting to the understanding, we are going beyond. Over that mountain is another mountain they'll need to climb, and they'll need to take this learning with them. So your turn. In the chat, what systems do you have in place for capturing student understanding during mathematical inquiry? I'd love to know your thoughts. Maths talks are great. Stations are great, yes. I'm assuming, Nicole, that means they've got like a rotation or a choice board, and then you work with the group while others do independently, and you can figure things out. Is that what that means? Yeah, super. I love that too. Exit tickets are amazing. Yeah, centers. All those things give you rich opportunities to spend time with the group and sort of dig into those skills and understanding, or target a group that you're wondering about. Yeah, I'm glad to see Number Talks. Number Talks changed my life as a mathematician. I was teaching grade 5, and the children would be like, are you learning this too at the same time? And I was like, yes, I am. They're great. Yeah, a bit of portion from transfer stage of each understanding. Oh, I like that. So kind of giving each time a little bit of like, where's this going? A bit of stretch. That sounds interesting. Google Forms. Brilliant. There's loads of great ideas. Number Talks are short talks Usually the ones I've always used are Cherie Parrott parishes, and they're structured talks to help children develop multiple strategies in the correct context for adding, subtracting, multiplying, dividing. And they're really quite transformative if used well. Yep, it is definitely too popular to miss out. You heard it here first. Great. Thank you, everybody. So what we're really lucky is, as you brought all those things into the chat, when you look at the inquiry cycle, there are those opportunities to bring those in. Like, for example, investigate's a really good time for those stations, that idea of stations. And you can work with a group then, or you can let them independently, and they've got all this time to practice that fluency and start investigating those conversations and those connections between your concepts. The focus, the concept formation area in focus is so important, the assessments there, to make sure they actually understand each of the concepts individually before you start going and investigating those concepts. And the hugely important one there will be the organize as well. It's worth saying here, and I feel like this might be obvious, but I know I've done it in the past. It is important to get round to the transfer and not just finish it, investigate and go, oh, the children have done lots of stuff about this thing. They've investigated, it's great, and leave it. We're going to look at the importance of the organize phase and the generalize as we're coming up, because that's what we really want to have a good look at. So when you're assessing, generally around about the sort of focus, investigate, organize phase, around this sort of part, that's generally knowledge and skills. And then as you move around from organize into generalize and transfer, you're getting that conceptual part. So if you think about synergistic thinking, you can see how it starts to come in around at the bottom of the inquiry cycle there and move around. So here we go. This is what we were all about. How can I use their generalizations as assessments? They've survived the terrain. They've climbed the mountain. You've got past all the assessment points. Everyone's eaten their sandwiches, and you've got to the top here. So how are we going to use their generalizations as assessments? Remembering, of course, behind that mountain, there is more terrain. They have to take this with them, and the generalization will help them to do that. So the first important question, are they ready to generalize? If you're new to CBI, I remember that was my big question. I was like, I don't know. How are they ready to generalize? And it's okay if you give it a go and it all goes to custard. At least they've tried one more generalization than you ever did at school. And, it's really give it a go. And then say to them, hey, I thought that was going well. And it's not. Let's go back. Okay. So I've done that plenty of times. I've walked into the classroom and thought, today will be generalization day. And then I'm like, no, today is not generalization day. Something's gone wrong. And it's usually to do with something in the way I delivered the lesson and get it there. But the kids usually will let you know when they're ready to generalize. But the most important part for you as a teacher is the organize phase. Organize phase really brings together that thinking at the factual and the conceptual level. That synergistic thinking starts to come together here. It really firmly establishes those connections and relationships between the ideas. This is the big bit. It reduces cognitive load. If you were to finish it, investigate, there's a lot going on there, and they're kind of figuring stuff out. And if you just moved on from there, you leave them with quite a cognitive load. Think of those Tetris blocks. They've kind of got some of those still going around. But when you get to the organize phase, you allow them to organize those Tetris blocks so everything kind of sits. Okay, so that's the real important part of the organize phase. So I sadly didn't have any, but my fabulous friend Michelle has provided me with some wonderful organizers from her school. And these you can see on the right, I've got the conceptual understanding we're heading towards and the organize phase. So in this one here, the children will have done a lot of investigating shapes and how we classify them, 3D shapes. And you can see now they start to bring them together. And that's going towards this idea that people identify 3D shapes using number and shape of the faces. So this is from grade 1. So you can see it gives them an opportunity to go, well, how did I know that was a cube? How did I know that was a cone? and a pyramid. And you can see this child is probably on their way and will get to that generalization in their own form. This one here helps the children to bring together all these case studies of different numbers and find the patterns between them. And they're working towards that understanding that expanded numerals help people to understand the value of each digit in a number. And so this helps them to reduce their cognitive load and goes, okay, I knew the value of 134 because I see the 100, the 30, the 4, I add them together. That helps bring it together. I love this one because this brings history to mathematics and broadens it out. But here, it's all about why we use the place value system. It's not something that adults invented to torture children. We use it for a reason. And here it says, a place value system uses fewer symbols than other number systems, which makes it more efficient. So here they've had a really deep investigation into other number systems. And we do use other number systems right now. But they start to be able to bring together like, okay, I'm beginning to see why we use the place value system over, for example, tally marks or Roman numerals. And this one here about division. We're not just doing division word problems. We're really looking into that division can be used to solve both sharing and grouping problems. So we're taking it down to really a depth that I know I didn't do at school, and helps bringing that idea of when do we share, when do we group? How do we know? What is that? It's really empowering them as mathematicians. And from there, when you get that feeling of like, I think they're ready to generalize, we're going to move into the generalize. And that's where the synergistic thinking happens. That's where we get the big picture transferable. That's where we're making the connections. And this is where we start to be able to use even more inductive stuff when we read the children's ones and ask them, well, how does that happen? Or why does that happen? So before we go any further, I showed you this generalization right back at the beginning. I'm not expecting you to remember. And I know I'm throwing you all in the deep end. But for example, here's a conceptual question. You write your own generalization, add it to the chat. How do people classify and name angles? So there's our little word bank. By the way, classification is the concept, but you can alter it to be classify if you need to so it fits in. So have a go. I understand that people... How might you do that? Give me a generalization, give it a go, because we're going to then assess our own generalization against the actual one. You don't have to. You can write your own at home and keep it secret yourself if you don't want to put it in the chat. That's fine.
Patrick, while they're working on their generalizations, there was a question from Anne. Did the students come up with a generalization or the facilitator?
Let me see. So the students come up with a generalization in response to the conceptual question. But there have been times when I've created class. If you're talking about me as the facilitator, I have created class generalizations where we bring together a lot of ideas so I can model how we can create one, or a group generalization if that helps, because that helps become more inclusive. Not all children will be able to write a generalization. And also I'm very aware that writing generalizations might be, for the older grades. So if you're working in early years, thinking of the Reggio sort of 100 languages, they can express their generalizations how they wish. You could get them to speak it and they record it. I hope that answers your question.
Yeah, I think probably also the key piece to that is the facilitator. You've seen the generalizations that Patrick had on the side there. We write the generalizations first simply so we know where we're going, we know what questions to ask, we know how to design our learning engagement, but we don't show our generalization to students. So technically the answer is both. The teacher will write it, but they're not sharing it. And then the students will respond to the questions as Patrick's modeled here. Yeah.
And having that in the back of your mind at all times is important. It's also helped me be really specific with the language I use. We're going to see some examples in a minute, and it'll help you realize how important it is to be specific with the language you use. There's some great ones coming in here. I understand that people classify angles based on the amount of turn or rotation contained in the angle. Amazing. Whose was that? I can't remember. It's skipped up. I understand that people can classify angles by naming rotations. Great, you all pass. You're all grade 5 mathematicians. Classification and naming of angles depend on rotation with terms like acute, right, obtuse, and straight angles. Fantastic. Okay. And it's lovely to see other people's. And remember, you will have as many generalizations as you have people in the room. And that's the joy of it. So let's have a little look. I'm going to do exactly what Rachel told me not to do, which is show the students the generalization. But here we go. Now, the reason you don't show, some of you will have just had a moment where your stomach just dropped a bit and you're like, oh, I didn't get it right. That's not true. What you wrote was a statement of your understanding at this moment in time. And that's correct. Because this can be changed. It doesn't matter what mine was. It's your learning and you're constructing it and you're heading to the top of your mountain. I know what it is. So now I need to be able to assess what you've written against what I've written and how close it is. Okay? And I would never show the children this because you want them to be so proud of it. They need to take that learning forward. They also need to adapt it if necessary and go back and revisit it. And that's where a lot of magic happens as well.
So the other thing about sharing a generalization is if you share your generalization with students, you're effectively telling them, I knew this all along, and you've just got the answer right or figured it out. But if we don't share our generalization with students, it actually feels more like that the idea of agency, that ownership of the learning. Like I came up with this myself, not like the teacher knew and I got it right, but I've done this learning and this is what I now understand. So do try and avoid the cover and reveal situation because you're really robbing that students of the opportunity to own the learning, to say this is my understanding.
Absolutely. Yeah, it's not what's in the box. It's what they're doing themselves. So here we go. So these are, before that, some of the things to look out for. Look at how well students articulate the connection between concepts. Are there level 1 verbs? In maths, generally in primary, you're not going to get influence, impact, and effect. I've not found that. But is, are, and have, you probably will. Also in maths, you don't generally get judgment and value statements. Not like people should do this in maths. But, you need to look out for that. What I also get the children to do is get them to write a few generalizations. Have another go, try it again. And then they start to kind of go, oh, actually, sometimes they take a bit from one, a bit from another, and then cobble together their last generalization. So they don't have to just do one, give them a few swings with the bat. And also something for you to consider as a teacher, you know where you're going with the transfer phase. You know what's coming up because you've mapped your learning terrain. So the question you need to ask yourself is, how will this generalization stand up to transfer? And that's often a kind of like a time where you think, okay, I think we need to go back. We need to go and dig in somewhere else because we've missed a point as a group, as a class, or this child just needs a little bit of hotspotting effectively. So consider as well your triangulation based on what you know about the student. Do you think it fits? Also, here's a really important one with mathematics. Students can often generalize in mathematics without being fluent or having mastery of the skills and knowledge. And that's okay. It's good to have that understanding because it will encourage them with building that fluency. They see a reason for it. They start to know why. So they let them generalize without having that fluency. That's okay. If they're ready, if they're understanding it, that's great. And then just provide opportunities for them to practice. So how would we follow these? How would we assess these following generalizations? So at the top, I've got the understanding, followed by the conceptual question. That's the one we've just done together. I've got the child version, and then I've written it for people who maybe don't always work with primary and need to be able to see it written clearly. So here, this child's written, mathematicians describe angles and lines using measurement and classification, such as using protractors to measure degrees and angles. Write in the chat what you feel about that. Have they got it, or is there something else we need to go back and dig into? Oh, there's a great question there while people are adding. Someone said, when do you work on procedure fluency, thinking about the inquiry phrases? Well, you're in control of that flow of learning. And if you've got stations, you can build it into an inquiry bit and you can just say, look, here's some practice time. Okay, so you can sort of pause your inquiry a little bit sometimes to work on those things, as long as they have the context around it, or find ways in and out. It doesn't always have to happen in your maths lesson as well. You can also use really good online programs that help build fluency, when they're coming in the morning or stuff like that as well. So it doesn't always have to be in that inquiry time.
Yeah, so it could be in the investigate phase. Like Patrick said, definitely part of a phased approach is that some students are working with the teacher and others are practicing and building fluency. But the other thing is it's part of the transfer phase from an inquiry approach. Like if you're specifically looking at the model of inquiry, after they've generalized, they then practice that understanding in new and different contexts, and that helps to build fluency as well.
This is great here. Can you measure a line using a protractor? The line concept doesn't fit. Yeah, I think we looked a little bit at line in there in part of the inquiry. So I think that's brought its way in. But yes, you're right. They're focusing on the tool. But what does the tool measure? It measures rotation, and we're missing rotation. So instead of using the word rotation, they've decided to name the tool. So is that good enough? So what I would think I would do here is go back and talk to the child, get them to write it again and say, hey, there's 4 concepts in the bank. Do you think you could maybe try and get them all in? Have another go. All right, let's look at the next one. Sorry, I have to move the chat box so I can see. Mathematicians describe angles and lines. So we've got lines again, it's come in, by classifying them as different types of angles. Okay. Mathematicians measure angles using degrees and thinking about rotation. I just want to say I love it when children write thinking about rotations. I suddenly have this image of a mathematician sitting somewhere going, thinking about rotation. And I know what they mean, but it doesn't quite, it needs a bit more sort of oomph in there, doesn't it? What do you think? Let me know in the chat what your thoughts are about this one. Yes, they might need more explanation on types of angles through different rotations. Yeah, what about rotations? Not quite there yet. It's kind of, close, but no cigar. We're on the way. All right, let's look at the next one. This one I want to share with you because it's one of my favorite generalizations of all times due to one spelling mistake, which brought me so much joy reading it. And it's just so cute because they've exchanged the word angle for angel. And I just love the idea that you might meet 6 kinds of angels, and one of them is an obtuse angel. I would very much love to meet an obtuse angel that seems quite unhappy in their work. But ignoring that cute little mistake, what do we think? Mathematicians describe angles, but going back to protractors and rulers. So they've got the idea that you use 2 different tools for 2 different things. They also use measurement and classification to find out what the angle is. And after measuring, they can classify them. And then they've really given us examples. What do we think? Yeah, they get the concepts, might need more tweaking, but the examples show the understanding. Yes, I'd agree. Yeah, they're just missing that rotation part. So clearly, this is what I mean about being specific with your language. As a teacher, I was thinking, have I actually intentionally used rotation, or did I just assume it was kind of going in? So I think we went back and had to go back and explore some of the case studies about getting that idea of rotation. So that was a moment for me to reflect on my teaching. So some red flags to look for, I've found over the years. You just get a definition of a concept. It doesn't show the connection. Not using all the concepts, that's something we identified. This is my favorite one, repeating concepts without showing strong understanding of connection. It's what I call a word salad. You kind of get this sort of graphs are data because data is graphs and graphs are data. And it just is this endless sort of like word salad. It's like bits of meaning and you're like, okay, you haven't got it. And then lack of examples and a follow-up. So quite often I'll sit with the child and go, so tell me more about your generalization. Can you give me an example about that from our organized phase? And if they can't, then you know it's not quite linking together. So here's a few more. This one's about place value. Extending the place value system to the right allows people to include fractions. So the question was, why was the place value system extended to the right? What I loved about this one is the crossing out. Crossing out is magic because you see their first attempt at thinking. It's almost like they put the wrong leg in the wrong trouser leg and they have to kind of fix it. And here also, I love the spelling of trying to, Tryna, Tryna. Love that. I understand that they were trying to take away 10 times and then there's a stop. Then she changes to, it's important that we can measure less than a whole to get an accurate answer. Oh, that's giving us so much. It's quite tantalizing, isn't it? It feels close. What are your feelings about that one? Would you say that's okay? Or is it's kind of getting there? We've got fractions, but it's not. It's less than a whole. Do we count that? Is that okay? Is that their version of it? Yeah, there's someone who's written in, maybe they need to build their math language to express their understanding more thoroughly. Exactly. And that's also lies with me as a teacher, that I hadn't been more intentional with how we use the language. Not there yet. Somebody's saying, kind of. It's tantalizing, isn't it? So maybe go back, we look at it again, and then we give them another chance. This one. I understand that decimals help when you need exact and perfect timing, or for other occasions. Now, I know what happened in this because one of our case studies was about ordering the race times of an Olympic 100-meter race and putting them all in order because everybody came in 10 or 9 seconds in the race, but the decimals helped us. So this child is only falling back on one example, one case study, and they've just put or other occasions. So we need to see, is that learning transferable? Do they really understand? And did they mean fractions by decimals? So we're on the way there. It's close, but not quite there. Here's another one. I understand that decimals can make life a lot easier because it's so much more accurate than just having whole numbers. Kind of. All right? We're kind of getting there, but we're not expressing it exactly right. So that would be, I think with this one, and knowing this child, I know exactly this child is very competent calculator. And I would speak with him and kind of go, can you tell me a little bit more about what you meant? And then maybe I would add that thinking, because I think it's pretty strong, this one. It's getting that idea of accuracy and that we can't just have whole numbers. He hasn't quite expressed it using fractions or place value. Yes. Yeah, more of a disposition and an understanding. I love that. Okay. This one. I understand that if it was extended to the left, it would be a higher number. And if you extend to the right, it would get smaller. This one feels like the child was almost in the wrong phase because this is kind of, it's just a sort of like a generalized sort of how numbers kind of work. So this one would have been, I wouldn't have gone for transfer for this one. We needed to go back and look at more stuff, and there needs to be a bit more practice in there because I think they've got it. They certainly don't seem to understand that it's fractions. And I think this might be the last one. I understand it was extended to the right so it could be more accurate. Clearly we used the word accurate in this thing and they've taken it to mean fractions. And if it had not been extended to the right, then nothing would really be accurate. So again, it's tantalizingly close. It's helping us, but it's not quite there. So the real kind of test of your generalizations is that transfer phase, is bringing it through. That's your real summative assessment. And once they've got their generalization, sometimes I would let them go and use it and see how well it stood up and whether they needed to go back and alter it. So sometimes when you've got your generalization, you go back into the organizer, investigate, or sometimes you sort of go, okay, go into the transfer, see how that works, and then come back, depending on what you feel like they need. So for that one, the transfer phase helps you to test and justify generalizations. They apply them in new contexts, near and far transfer. And what I love about the transfer phase as well, especially if you're doing data, is about taking meaningful action. I think that's always a beautiful one. So the transfer for that last generalization was about these joeys that had their burrow destroyed, and the vet had to weigh them to see if they were undernourished or not. And actually, I was quite amazed by the amount of maths that just seemed to explode over their pages. And there was lots of stuff from the pre-assessment, from all the investigation that came out, these number lines, these graphs that started to show that actually, although maybe they hadn't articulated the generalization particularly well, there was a lot of understanding there. And then we could go back and work on their generalizations to sort of say, what would you change? How would you do that? So you can see here they had to order them because I think if you didn't have fractions, decimal fractions, 3 of those wombats would weigh the same. They would weigh 3 kilos and 1 would be 2. And I just thought that the amount of maths that exploded on their pages here was really quite pleasing. And helped me understand how good their generalizations were and how well they put them together once they'd had a chance to rethink. So that's been quite the journey. In our CBI maths, this is what our assessment looks like. That idea that we have a pre-assessment, a mess about, we have our skills and knowledge, the student generalization, the transfer tasks, the ongoing teacher observations, all supported by student reflections. And that's even, I've used the word triangulation, but actually that's so much more than a triangle. How many are there? 5. It's the pentagon of assessment. And then when I looked back, I thought about this, that actually generalizations can be a golden thread that runs through your school. Because if you record the generalizations, keep them, if they have a generalizations journal, they can get passed up to the next year. It really helps them know that this learning did not just belong to last year's teacher. This learning belongs to me, and I take it through. And then it adds to that longitudinal assessment in the school. And you can start to really build a picture of the child as they move K to 5 and how they do those transfers. So you've got the school longitudinal data through using conceptual understandings, and you've also got your summative for your own units mixed in with your formative. And I do think it's quite powerful because it makes that triangulation, it's almost like a golden circle around the child. It brings that assessment data, the student reflection, because a generalization is effectively partly student reflection, and it's your teacher judgment, and really helps bring together that sort of like that judgment you're going to make about the child when you report back and when you build an assessment arc for that child through school. So I have 3 questions for you. You do not have to answer all 3. You can if you want to show off. You can choose one of those questions, and I'd love you to put the question letter in the chat and give me your answer so we can see. There's one about you can write your own generalization. How do people use student generalizations in their assessment data? You can just give me a reflection on why is it important for students to write generalizations, or just a bit of feedback. What was new learning or something helpful for you in this session? I'd love to see those in the chat. And then we'll have time for questions after. And there'll be a slide showing you how you can follow my work. It's all, I've thought it all out. Thank you. To empower them by agency. I love that. They empower. Yes, they are the ones in control of their learning. Yes, they do work in maths. That's wonderful. Thank you, Margaret. Well, these are all whizzing by. I might have to make my chat box a bit bigger. Yeah, oh, good. I'm glad you're taking the colouring for the pre-assessment. That's a game changer, and it really adds as kind of a filter to their work. Oh, I'm glad you found seeing the generalizations in maths that you can see how much information you're getting and where they're thinking. That's wonderful.
Yeah, coming through quite consistently is writing generalizations in maths is new for me. It's great. And just remember that if you want to write generalizations in mathematics, you have to be clear first as an educator what it is that you want your students to understand. Because all of your learning engagements and the questioning stem from your clarity and intent around what you want your students to understand. So spend some time working on that as a team. What in this unit, what do we want students to understand? And it's interesting because there was a number of comments throughout your session, Patrick, in the chat about, I'm clear on this, how this works in shape and space or in data, but it's really tricky in number. And so we have to become more articulate as educators in number and number sense particularly, and in number operations. What is it that we actually want our students to understand? It's not just procedural rote learning of this is how you find the answer to the equation. We actually need them not just to be able to solve it, but to be able to understand that.
Yeah, and it goes back to that learning terrain. We're not just letting them wander off. We need to make sure we know our routes, where we're headed. We don't want to get lost because that's when it gets dangerous. Thank you so much for all these. They're wonderful to read, and I'm really glad it's been helpful for you. So now,
Patrick, there's going to be lots of students writing notes to their teachers on their maths assessments going forward, which is exciting to see. Color coding.
It's so much fun, and honestly, it makes assessing just really sometimes entertaining when you get like a really comedy message and you're like, oh, bless you. And you know, the kid, one of them even did a smiley of a shrug, like it looked like that. He'd just drawn a smiley. And I was like, great, you don't know, that's fine. So if you have any questions as well, you can start typing those in the chat and we'll do our best. Oh, multiplying fractions, yes. I know what you mean. And I spent a long time creating word problems for context around multiplying fractions. Usually sort of like my brother ate half of the chocolate bar and then I kind of with the remaining part of the chocolate bar, and you're just like, oh man. So yeah, it is tricky. But
I think the key there I found, I've seen Calvin do a maths lesson on multiplying fractions, is that students are modeling it and they're actually cutting up the pieces of the fractions and seeing what's happening to that fraction.
The one I use is the kind of array, the closed array, where you have the whole. Let's say you're doing a half by a quarter. You have your whole, you half it, and they shade in a half, and then you quarter it that way, and you shade in a quarter, and the bit that was colored twice, that's your product. And that's a really great model for doing that. So if you have that, like Rachel mentioned about cutting them up, but also that highlighting bit, and then they start to see why your product is smaller, and it's the only time. And it's worth visiting that generalization of when you multiply, you always get a larger product. Not always. Sorry, Rachel, I talked over you there.
No, it's great. It's great.
Is it possible to have a group? Oh, with people attending. Well, we do we have groups, Rachel?
Well, I was just, in response to that, I was like, actually, maybe we just want to get people into, we've got a Facebook group that a lot of people will share ideas and things in. So I'll put the link to that as a starting point, and then maybe you can add another link in there if people want to create other math-specific groups.
Joao, the Mondrian painting, is that the Joe Bowler one? Because I love that. That's adding and subtracting fractions and using the primary colors. I love that one. They have to make a fake Mondrian and they love it. It's absolutely brilliant. Great. Well, there doesn't seem to be so many questions unless I've missed something. There was a lot coming in together. So if there's something that's really burning that you want to, I might have missed it, so put it in. But thank you for the thank yous. That's my details. And I shall hand back to Rachel. Thank you for listening. I feel like I've been talking at you for a long time, but I hope...
Can you go to the next slide, Patrick?
Oh, sure.
There we go. So for those of you who were asking about the CBI Maths project, the Maths project was developed really as a passion project. I was working at an international school at the time and found we spent so much time writing curriculum that we didn't have the time to spend on implementation. So a group of teachers from all over the world got together and developed the CBI Mathematics Project, Patrick included. He introduced himself as a writer in the CBI Mathematics Project. And we've designed this for elementary teachers and schools who want to master a concept-based approach. It really is a done-for-you approach. We've written a full scope and sequence from kindergarten right through to the end of grade 5, and at the moment we're extending into grade 6 and grade 7 for that. It has all of the learning engagements written, all of the pre-assessments are already written. So if you want to find out more about that, there's a QR code or there's the website there. I'll also pop the website into the chat for anybody who is interested in finding out more about that. It is a membership program, so you can register as an individual teacher or as a school. So if you've got questions about that, just send us an email and we can to sort you out there.
I just want to add on to that I've taught maths in so many different ways over the years and sometimes phenomenally badly. But this project, and I'm not saying it just because I actually really believe in it, and I think it's the best I've ever taught maths, and I felt it like as a teacher, but also what I noticed, the student engagement was massive. And the thing that I noticed the most were those children who didn't see themselves as mathematicians at the beginning of the year. Their voices grew, and I could see them start to ask questions that they would never have dared to ask in August. The first year we brought it in, and that to me was just those magic moments where you can feel children start to view themselves as mathematicians. And I don't think I've experienced that with anything else before. So I'm not just being biased. I've taught it and I loved it, and it's a great thing to teach.
Thank you, Patrick. So there was a question. It's only for the PYP at this stage. So at the moment it is, but by next year we'll have the first couple of years of MYP as well. So it's not only for IB schools, but a lot of IB schools do use it. And I know the question was coming from somebody from MYP as well. So yes, we are looking at extending that through to middle school. We've already written the scope and sequence. So watch this space. All right. Well, thank you so much for joining us. It's wonderful to bring together a group of teachers who are passionate about mathematics education. It's definitely a passion of mine, and I know of Patrick's. We hope that you feel inspired now to try some new strategies in your classroom and just invite your students to start generalizing.
Yes, thank you, everybody, and thank you for your participation. I've really enjoyed it.
We'll see you next time.
Yeah.